Hello student, this is Rimpa Singha Roy and today we are going to solve some problems, some special type of problems on equivalence relation. So without any further ado, let's look at the problems. So now here is the question. This is special type of question because of this, because rho is a relation on n cross n. Before this, we have solved some questions like n to n. But this time it is n cross n and this is n cross n. Okay. So that means rho is a subset of n cross n cross n cross n. Okay, and so the element of n cross n will be like a b, a pair. Okay, and similarly it will be like c d, another pair, and it is defined by a d into b plus c equals to bc into a plus d. Okay, and we have to prove that rho is an equivalence relation. So let's go to the solutions. To prove the given relation as an equivalence relation, we must show that it is reflexive, symmetric and transitive. So first we will start with reflexive. Okay. So how do we prove a relation as a reflexive relation? Then we have to show the identical element AA belongs to the relation for all A belongs to the domain set. Okay, domain set. Here the domain set is n cross n. As the domain set is n cross n, then A will be like a pair AB, and then the identical element will be like AB AB. Okay, so if we want to prove rho as an reflexive relation, then we need to show that this type of identical element belongs to rho for every element AB of n cross n. Okay, so now let's start the proof. First, we have supposed that AB belongs to n cross n, and we have written this equation. This equation is actually similar to the given definition of rho. Okay, so as we have succeeded to written this equation, then we can say that AB comma AB belongs to rho. Is it clear? Now, as AB was an arbitrary element of n cross n, then we can say the identical elements AB comma AB belongs to rho for all AB belongs to n cross n. Okay, as we have proved this, that the identical element belongs to rho for every AB or every element of n cross n, then we can say that rho is a reflexive relation. So here it is proved. Now we will move to the symmetric part. Now the symmetric part. So how do you prove a relation as symmetric? First, we suppose that AB belongs to the relation. Then we show that BA also belongs to the relation. Okay. Similarly, here we have taken a point from rho, which is ABCD. As it is belongs to rho, then it satisfies the given condition. AD into B plus C equals to BC into A plus D. Now we can rewrite this equation as like this. Okay, there is no problem with that, it's actually same. So from this equation, the second equation, we can write that CD comma BA belongs to rho. If CD comma BA belongs to rho, then it will be like this. So as we have succeeded to write this equation from the given condition, then we can say that CD comma BA belongs to rho. So here we have taken a point like ABCD, and we prove that CD AB belongs to rho. So here rho is a symmetric relation. Okay. Now I'll move to the transitive part. This is the transitive part. It looks scary, right? Don't worry, I'll make you understand. Let me zoom it first. I think it's okay. Now, how do you prove a relation as a transitive relation? Then we have to suppose that AB, BC belongs to the given relation, and then we have to show that AC belongs to the relation. Okay. So here we have taken 2 points ABCD, CDEF. And how do you prove that rho is a transitive relation? We will show that AB, EF belongs to rho. Okay. So for this we have done so many things. So let's start from the beginning. As ABCD belongs to rho, then it satisfies the given condition like this. As CDEF belongs to rho, then it satisfies this condition. Okay. Now we have rewritten the relation and got this line. How did we do this? We just interchange BC and AD. AD, we have sent AD to the right hand side and BC to the left hand side. Okay. And then we have splitted the splitted the relation, like 1 by B plus 1 by C and 1 by A plus 1 by D. Then we have rearranged this. We put A and B, 1 by A and 1 by B in the left hand side and 1 by C, 1 by D in the right hand side. Why did I do this? Because if you look at these 2 points, there we need to show that AB, EF related relation. Okay. That means if AB comma EF belongs to rho, that means it will satisfy this condition. Then it will like be AF into B plus E equals to BE into A plus F. Okay. So there is no point like CD. So we'll eliminate CD from this two equation. So how did we do this? We put 1 by A, 1 by B in one side and CD related part in the other side. Similarly, we have done this. We put 1 by E, 1 by F in the left side and 1 by C, 1 by D in the right hand side. As this is also 1 by C minus 1 by D and it is also 1 by C minus 1 by D, so the left hand side will be equal to each other. We have put it like this. Okay. Now as we have done this, then they are equal. Then we just added them and interchange the denominator BE and AF. Then we have this equation and it actually shows that AB, EF belongs to rho. So we have taken any arbitrary element ABCD and CDEF, and we have succeeded to show that ABEF belongs to rho. So we can say that rho is a transitive relation. Now as rho is reflexive, symmetric and transitive, so it's also equivalence relation. Sorry for the handwriting. This is an equivalence relation. It's proved. Thank you so much guys for watching my video. Meet you in the next lesson.